Right, following on from my last video on linear simultaneous equations, let's have a look at some quadratic simultaneous equations. So in year 12, we're going to stick with quadratic simultaneous equations that look like this. Usually what you would have in an exam setting is perhaps a quadratic and a linear equation. But in this video, we're going to be looking at a quadratic and a quadratic. So just a little bit more complicated, but the principles are exactly the same. So when we solve the linear simultaneous equations, I used a method called elimination, which is where you take the two equations, you multiply it by a constant so that you can cancel one of the unknowns. In equations like this, because y equals this and y equals this, then immediately you can equate the two. And essentially what you're doing is you're using substitution. You're substituting one definition of y into the other equation. In this case, A, B, C, P, Q, and R are given to you. So these are all numbers that are given in the question. And X and Y are your two unknowns. What we're going to do then is equate the two. So if Y equals the top, that's AX squared plus BX plus C. And that's going to equal the Y at the bottom, which is PX squared plus QX plus R. Then you're going to create for yourself another quadratic equation which has coefficient P minus A x squared plus Q minus B x plus R minus C equals 0. And then that's just a quadratic equation in the form AX squared plus BX plus C, which you can solve using either quadratic formula or factorising or completing the square or your calculator. Doesn't matter, you will arrive at two solutions for x. Okay, so let's have a look at a numerical example. Here we have two quadratic equations, y equals x squared minus 4x plus 4, and y equals 2x squared minus x. And we're going to equate the two. So we're going to get x squared minus 4x plus 4, and that's going to equal 2x squared minus x. I'm going to bring everything across to this side just so that I have a positive coefficient of x squared, but you don't have to, of course. So it's going to be x squared plus 4x, so it's going to be plus 3x altogether. And then I'm subtracting 4, and that's going to equal 0. And then I can factorise that as x minus 4, plus 4, and x minus 1. That will then give me solutions x equals positive 1 or negative 4. And it's not uncommon to get two solutions for x in these equations. Once I've got a solution, I'll plug it back into one of these to check my y value. So plugging in x is 1, I'll get 2 times 1 minus 1, which is 1. And plugging in x is minus 4, I'll get 2 times 16, okay, because minus 4 squared is positive 16, so that's 32. Minus 4, so that's add 4, so that's 36. Those are my two y values, and they're in the respective order. Okay, so when x is 1, y is 1. When x is minus 4, y is 36. And then as your solutions, you should put perhaps as coordinates or certainly pair them off. So x is 1, y is 1 is one solution. And then x is minus 4, y is 36 as another solution. So there are these two solutions to this pair of simultaneous quadratic equations. Second example, exactly the same principle. We're going to equate the two. So x squared minus 4x plus 6, that's going to be equal to a half x squared plus 2x minus 4. I'm going to subtract the half x squared over this side this time, again, so that my x squared is positive, but of course you don't have to do that. Minusing 2x, it's minus 6x. And then adding 4, so that's plus 10, equals 0. And then I'm just going to times it by 2, just so that my coefficient of x squared is an integer. But again, you don't have to do that. Okay. From this point, yeah, I could factorise. I'm actually going to use the quadratic equation just to show you that alternative methods can be used. It doesn't actually matter what you do. So x is minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So that's going to be 12 plus or minus 144 minus 80 is 64. The square root of 64 is 8. That's divided by 2. So my 2x values then are 12 plus 8 over 2, which is 10, or 12 minus 8 over 2, which is 2. And just as I did in a previous example, I can then plug those back into my equations here to get my y coordinate. When x is 10, I get 100 minus 40 is 60, plus 6 is 66. And when x is 2, I'm going to get 4 minus 8, which is minus 4, plus 6, which is 2. And again, pair them off to give you your final answers of x equals 10 and y equals 66. And then the other pair, which is x equals 2, y equals 2. And that's how you should leave your answers. You could just leave them as coordinates. All right, so 10, 66, or 2, 2. Okay, that is absolutely fine. As long as you make it clear which x value goes with which y value. Don't just stop there. Okay, you won't get full credit. All right. Again, thank you for watching. And I hopefully will be making more videos over this third UK lockdown.